Welcome to part 20 of our series on building a Zelda-like game in Phaser 3. In this video, we'll complete our object interaction mechanics by implementing lifting and throwing. The player will be able to pick up objects and throw them, potentially breaking pots or hitting enemies. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and start smashing some pots. Now that our player can open up the chest in our game, we'll work on adding the ability for our player to lift up our pots and throw them in our game. For this change, we'll need to add two new components to our game. One will be a held game object component, which will be used for keeping track of the object our player is currently carrying, and the other one's going to be a throwable object component, which will be used when our player goes to throw the object in our scene. Besides our two new components, we'll need to make some updates to our existing states, as well as add a new throw state so we can update our game object's position when our player throws it across the screen. To get started, we're going to work on adding the ability for our player to actually lift up the object and then have it follow along our player as we move around our screen. For this change, we'll need to start with a new component. So let's go into our components game object folder. We'll make a new component. We're going to call this held game object component. We'll copy our code for our speed component. So for our class name, we'll do held game object component. And so for our property, we're going to call this object. We'll need to keep track of our game object we're carrying. And we'll also want to support undefined. So after our player throws the object, we'll no longer be holding one, but we'll still want to keep this component on our game object. For our constructor, we'll get rid of speed. Now for our getter, we'll get our object. So this will return our game object or undefined. And now we'll return our private property. Now we'll want to add a setter so we can update our object. So we'll copy this, let's paste it. We'll change this to set, get rid of our return type. Now we'll have our object, which will be our game object. And so we'll do this.object will be equal to that object. Lastly, we're going to add a new one public method. We're going to call this drop. And so this will allow us to drop the game object we're currently carrying. And so how this will be used is when our player throws our object, we'll drop it from this component. Or if our player gets hurt, we'll drop our game object and we'll call that same method. Now that we have our new component, let's jump over to our player class. Let's add our component to our player. So we'll do a new held game object component, and we'll pass in this for our game object. It's now for our player to be able to actually lift up our items. We need to go into our lift state. And so after reset our velocity, we'll want to grab our new component from our game object. So we'll do const, let's do our held component. Set that equal to our held game object component. Pass in our game object. And now we'll add in our safeguard. So if we don't have a held component, so if it's equal to undefined, then we just want to transition back to our idle state. So I'm just going to copy this here. We'll paste it. And we'll transition to idle. Then we'll return early. And so long as our game object has a held component, then we'll be able to lift up our game object. So on our component, now we'll need to store a reference to the object we're picking up. To do this, we'll need to add our arguments to our onInner method. And so we'll add in our args. And this will be an unknown array. We'll grab a reference to our first argument. So we'll do const. We'll do game object being picked up. We'll set that equal to our args, our first element, and we'll do as game object. Now down our held component, now we can store that reference. So we'll do our held component, and we'll do object will be equal to our game object being picked up. So now for our player to actually be able to carry our item, we'll need to disable our physics body on our game object. Otherwise, our player and that game object will keep colliding. And so we'll do if is arcade physics body, and we'll provide our game object being picked up. And we'll grab the body from that game object. Then we want to do our game object being picked up, our body, we want to call enable, and we're going to set that equal to be false. Besides updating our game object's body, we'll want to update its origin and its depth, so then that way we can center that game object over our player. So how depth works in Phaser is by default, all game objects have a depth of 1, and when they get rendered to our scene, they'll be rendered in the order that were added to our scene. So we'll see our display list here because we added our chest after our player. That's why our player appears under our chest. And as an example, if we go back to our game scene, if we move our code for our player creation to take place after we create our game objects, so if we just copy this code here, and now we place it down here, what will happen is now because it was added afterwards, our player is now in front of those game objects. Another way to handle this is we can update the depth on one of our game objects. And so as an example, if we do this, we do our player, we do set depth, we set this to 2, and so now what should happen is because our player has a higher depth in our rendering order, Phaser is going to render that game object on top of all other game objects for that depth. And so when we pick up one of our game objects, we'll want to make sure our depth is set to 2, so then that way it appears in front of our player, and that way we can make it look like it's on our player's head when we're carrying our pot around. So to make that change, back in our lift state, we'll grab our game object being picked up, we're going to set our depth to be 2, and one other thing we'll do is we'll update the origin on our game object so it'll be centered. Let's do set origin, and now we'll do 0.5 for both our X and Y. Now that we're keeping track of our game object that our player is carrying, now we can make changes to our move holding state to have that game object's position get updated as our player moves around our scene. So if we jump over to our move holding state, after we do our updates to our player, now we want to update that game object's position. So for this, we'll need to grab our held component so we can get a reference to that game object. What we'll do is let's copy our code here for we grabbed our held component. We'll paste that down here. Let's update our imports. So now that we have our held game object component and we've updated our player's position, now based on our player's direction, we can update our game object positioning. To make this change, we'll do if, we'll do our game object, our position, our direction is equal to direction down. Now we can grab our held component, we'll grab our game object from there. We'll do set position. Now for our position, we want to update our X and Y value. So we're going to reference our game object's X position. And we're going to add a little bit of an offset so that way our game object's a little bit more centered. And so we'll do this dot game object as well, Y, and we'll do -2. And so one other check we're going to do up here to our safeguard is we're going to make sure our held component actually has an object, so then we don't have our optional chain here. And so if our held component's undefined, or a held component dot object is undefined, then we want to go back to our idle state and we can remove this check here. So now if we copy this code, we'll do our other directions. And so we'll do else if our direction is up. Then we'll update our X value by 1, but then for our Y value, we'll subtract 6. And then finally, we're going to do else. And so when we're facing left or right, we'll change our position. And so now we'll just do our gameObject.x, and we'll do our Y, and we'll subtract 8. And so one last change we'll do is we're just going to check to see if our flipX property is set on our game object. And so if it's true, then we're just going to reset our X position on our held game object, so then that way it'll be centered. So we'll do our held component, our game object, and we'll do set X, and we'll just do with this, our game object, and our X value. And so all we're doing here is we're just updating our X and Y value on our game object, and we're adding in an offset, so then that way our game object will be more centered depending on how our player moves around our scene, because we updated our player's physics body. And this will make more sense once we actually do our testing, since we'll comment it out and see what the object looks like. So now in order to test our changes, we just need to update our lift state to receive our game object that we're actually lifting up. So to make that change, let's go into our move state. And when we transition into our lift state, we'll also want to pass in our collision object. Alright, so we want to test our changes. Let's come over to our pot. If we have our player lift up our pot, we'll see right away our game object, we update our offset, and we don't have it above our head because we didn't move our object as part of our lift state. But now when we go to our move hold state, we'll see our object's position is updated as our player moves around our scene. And so if we come back to our move hold state, if we just update our code to be held game object object, if we do set position, when we do this, our game object, our X, this, our game object, and our Y, we'll just comment this out real quick. What will happen is after we pick up our game object, we'll see that it's covering our player's head. And so by adding in that offset, we just move that game object above our player, depending on our direction our player's facing. And so by tweaking those values, we can change our game object's position wherever we like it to be. Now that our player can lift up our game objects, we're going to work on giving them the ability to throw them. To do this, we'll need to add a new component to our game. So under our components folder, under game object, let's add a new component. We're going to call this throwable object component. So in this class, I'm just going to copy our code from our held game object component. We'll update our class name, and we'll just do throwable object component. On our class, we won't need to keep track of our object, but we'll add a new property. We're going to call this callback, and so this will just be a callback we're going to invoke after we throw our game object. And so for our type, we'll just have a function that doesn't return anything. And now we'll update our constructor to have that argument, so we'll have callback. We want this to be optional, and so we'll just add in our default, and we'll return undefined. And now we can do this, our callback will be equal to our callback. So now on our component, we don't need any getters or setters. And so for our component, we're just going to have two methods. We'll keep our drop method here. And so when we drop our game object, we're just going to call our callback that's been registered. And then we'll add in a method for throwing our game object. So let's copy this. we'll paste it, and we'll do throw. And now when we throw our game object, we'll need to know which direction our player was facing. And so we'll have direction, we'll add in our type. All right, so for the time being, all we're going to do is we're just going to add it to do, and we're going to come back to our throw method after we create our throw state, so then that way we get everything wired up and working properly. So now to create our throw state, let's go into our states, our character folder. We'll make a new state. We'll call this throw state. For this state, I'm going to copy our code from our idle state. We'll update our state name, and we'll do throw state. We'll want to add that to our character states. So now when we enter our state, the first thing we'll do is we'll reset our body's velocity. And after we do that, we'll want to play our lift animation. But for our lift animation, we actually want to play this in reverse, so then that way it looks like our player's throwing the object instead of picking it up. For playing our animation in reverse, we're going to add a new method to our animation component. So we're going to call this method play animation in reverse. Let's open up our animation component, and now we'll add in that new method. And so for our play animation in reverse, let's just copy our logic here for our animation method. Paste this, we'll do play animation in reverse. Alright, so for our method, we'll keep our optional callback. And so first we'll check to make sure our key actually exists under configuration. If it does not, we'll do our callback. If our key does exist, we'll create our animation configuration. So we keep the same key, we'll use our repeat property. But then for our timescale, we want to set this to be 1.75. And so that way we'll play it in reverse a little bit faster. And then finally, when we go to play our animation, we actually want to call our play reverse, and that way we'll play our frames in reverse order. So now if we come back to our throw state, so after we play our animation, now we want to reference our held game object component and our throwable object component, and we'll want to throw our game object and drop it. For this, let's go into our lift state. I'm going to copy our code here where we grab our held component. We'll paste that here. Let's update our import so we have our held component. If our held component's undefined, or if our held component game object is undefined, then we'll just want to return early. Next, we'll grab a reference to our throwable object component. And so we'll grab our throwable object component. For a variable name, we'll do throw object component. And so if our throw object component is not undefined, now we want to reference our component and we'll call our throw method. And now we'll grab our game object's direction. And then finally, now we just want to reference our held component and we want to call drop so we can drop our game object from that component. So now down in our onUpdate method, all we want to do is check to see if our animation's playing, and if it is, we won't do anything. And then once our animation is finished, we want to go back to our idle state. So let's do our idle state. Now let's update our code here. And so let's do if this, our game object, our animation component, is animation playing. And so if that's true, we'll just return early. Now if we want to test our changes, we'll need to add our new class to our player. So let's open up our player class. Let's add in our new state. So I'm going to copy this line here. Let's paste that in. We'll do our throw state, and we'll pass in this for our instance. Now we'll want to open up our pot class. We'll want to add in our new component. So we'll do our new, and we'll do throwable object component. We'll pass in this for our reference. And now for our callback. And so now once we throw in our game object, we're going to call a new method, and we'll do this.break. Let's add that method to our class. And so we'll do public, we'll do break. We won't return anything from our method. And so after we throw our pot game object and it's time to break it, the first thing we'll do is we're going to disable our physics body on our game object, so objects will stop colliding with it. And so we'll do this.body as our phaser physics arcade body. We'll do enable, we're going to set that to be false. Once we disable our body, now we'll want to play our animation for actually having our pot break. For that, we'll need to update our game object's texture since this will be in a different asset. And so we'll do this, we'll do set texture, we're going to do our asset keys, and we'll do our pot break asset keys. And we'll do our first frame, and now we'll do our animation, so we'll do play, we'll do our asset keys, and we do our pot break animation. Finally, once our animation's done, now we'll want to reset our texture to be back to the original texture, and we'll want to hide our game object from our scene. So we'll do this.once. We'll do our phaser, animations, our events, and then we'll do our animation complete key event, plus our asset keys, and we'll do our pot break. And then in our callback, we're just going to reset our texture, so we'll do this, we'll do set texture, we'll do our asset keys, our pot, we'll do our first frame, And now we'll want to hide our game object from our scene. And so for the time being, I'm just going to comment this out. Let's do console.log and we'll say hide and we'll come back to this. So now if we want to test our changes, we need to update our state machine. And so if we go into our move holding state, when we do our check to see if our action key was pressed, we currently transition to our idle state. And so we'll want to change this to actually go to our throw state. And we'll want to make the same change in our idle holding state. So we'll get rid of our to do. And now let's do our throw state. So now what we should be able to do over in our scene. Alright, so now when our scene refreshes, we should be able to test. So if we move over to our game object, let's pick it up. If we try throwing it, looks like we have a bug. Let's go into our throw state. Yes, so when we grab our throw object component, this isn't on our game object for our player, so the one we're moving around. This is actually on the game object that they're carrying. And so let's update our code. It won't be this.gameObject. Instead, this will be our held component, and then our object from there. So now if we go back to our scene, we should be able to test. Let's pick up our game object. Now when we throw it, we'll see we update our asset, but then we're missing our animation for our pop break. And so to fix that, we just need to go into our preload scene, where we create our animations. So now for our pop break animation, this is just another sprite sheet. And so we need to copy our code for what we did for enemy death. And so we'll do our pop break. We need to generate our frame numbers from our sprite sheet. And so our only frames are tied to this animation, so we'll keep our default values. We'll update our asset reference, and we'll do our frame rate of 6. So now if we come back to our browser, let's pick up our pot game object. And now when we throw it, we do our animation for our pop breaks, and we see our console log message for hiding our game object is now working. And if we want to make sure our physics is working properly, let's open up our main.ts. Let's enable our debug. So now let's grab our game object, let's throw it, and we'll see that our game object's body is not around our pot when it breaks, and it's still disabled from when we initially disabled it. Nice. Now to hide our game object after we throw it, we're going to add a new method to our class called disableObject. This method is going to be responsible for disabling our physics body on our game object, as well as making our game object not active and not visible. By doing this, our game object will no longer show up on our scene, and we'll no longer call the update method for that object when it's no longer visible. We'll be able to reuse this logic later on once we start adding in our dungeons and we want to hide game objects when our player leaves a current room. And so in addition to our disableObject method, we're going to add an enableObject method, which is going to do the inverse, where it's going to re-enable our physics and then remake our game object active. So now to add those methods, we'll start with our disableObject. So we'll do public disableObject. Let this return nothing. And so now we're going to reference our physics body. So we're going to do this, our body. We'll do as a phaser, physics, arcade, body. We'll call enable. We're going to set that to be false. Now we're going to do this.active to make our game object not active, and this.visible to hide our game object. So if we copy that method, let's paste it, and now we're going to do enableObject. And now we'll just do the inverse, so we'll set all these properties to be true. So now down in our break method, in our callback for our animation, we can update our texture. Let's get rid of our console log statement, and we'll do this, and we'll do disableObject. So now back in our scene, so now if we test, let's have our player pick up our game object. Once we throw it, we'll do our break animation. Once it's completed, we now hide our game object from our scene. So these two new methods we just added, this is a pattern we've already used in our game for our character game object. It's also a pattern we're going to want to use on our other game objects, so then that way we have this in common across all of our game objects in our game. Since this is something both have in common, we're going to abstract these away to an interface, and then we're going to expect our classes to implement that interface. To do that, let's go into our common types file. We'll make a new interface, so we're going to do export, interface, we'll do custom game object, and for this interface, we'll have enable object, we'll have this return nothing, and now we'll do disable object, we'll have this return nothing. Also with our new interface, we're going to add a utility function for checking the type of our game object to see if it is an instance of our custom game object. This will be useful later on as we're iterating through our game objects in our game to see if it's actually one of our custom types. So let's do export, we'll do function, we'll do is custom game object. And so we'll have our game object for our argument, and we're going to type this as our game object we've been using. And now for our return value, we'll say game object is game object, and it'll have our custom properties, and so we'll do our custom game object. So now for our check, we're just going to return if our game object has our disable object property. So if it doesn't equal undefined, and it has our other property. So let's just copy this here. Let's paste it. We'll do enable object. Now we'll save. So now back in our pot class, let's go to the top of our class and we'll do implements, custom game object. And then let's jump over to our character game object class and we'll do the same thing. So we'll extend our phaser physics arcade sprite and we'll do implements, our custom game object. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching and I'll see you in the next one.